Hello and welcome to a final segment on topographic maps. This will cover topographic profiles, both how to plot a topographic profile, which is actually pretty straightforward and pretty simple. And then the second step that you'll want to know about for your lab is how to calculate vertical exaggeration. Vertical exaggeration is the stretch on any topographic profile we sometimes apply to make it more visible. The profile itself, if I talk about it briefly, is basically, think of it as like the shape of a skyline, a series of buildings. Buildings have their own kind of shape, and you can recognize them, such as the John Hancock or the Sears Tower, right? So this makes sense from that perspective. So then if I take a look at erasing this, take a look at the profile for a hill or something. Here's a hill. Looks like this and then comes back down like that. Right, so this is the side view of a hill. If you wanted to make it into a volcano, you could do that as well. Side view of volcano might be more like that, and then back down like that. So it sort of looks flat from the side, or potentially even make it slightly different. You can look at the side of volcanoes. You come up the top, come up the sides, go down into the crater, come back out, and come back down again. Right. So that's your profile. That's your side view. Vertical exaggeration is when we stretch that view using scales on our topographic profile box. And so if I was to redraw this, it might look like this if I stretched it times 2. So you notice from here to here, it's almost twice as tall. And I stretched it, but I drew it within the same horizontal distance, more or less. Okay, so that's vertical exaggeration, and all it does is help us see more clearly the topography, especially in places where the topography is quite flat. In Illinois, right, a stream might be subtle, boom, boom, and that's it. This little divot might be a stream. That's because there isn't much elevation change, 10 feet, 15 feet, something along those lines. And so that means we need to stretch the topography out, or the vertical changes in elevation, to make things more visible. First, you need to have a map, okay? And so that's what we have up here. On the top right-hand side, we have a map that's been drawn. And you're going to pick a line along which you're going to draw the profile. So A and A prime, or A and B, however you want to look at it. And what this is sort of tantamount to do is be like you walking. What's it going to be like when you walk along the line? So if I walked from A to A prime, I'd be walking uphill to 200. I'd go over a little saddle. I'd walk downhill. So this is up, down to the stream. Now I'm walking up a long slope, up, 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 and I'm at A. So I'm back uphill once again. The process is very easy. We've given you a box with a scale. That's the side view. That's the vertical scale. Your vertical scale can be the same as the map scale, in which case you'll have a vertical exaggeration of 1, and 1 times anything is just 1. So there's actually no exaggeration when the vertical scale and the horizontal scale are the same. This particular example I'm showing you, I have not identified, and there is no map scale, so I can't identify exactly what the exaggeration is, but I will show you how to calculate it. So once you've picked your line, you're going to take a strip of paper. It could be a partial strip, but you just want it to cover from A to A prime, from A to A prime. And then everywhere a contour line intersects your piece of paper, you're going to put a mark, and then you're going to write the value of that contour line. So 160, 180, 200, notice 200 here, then 200 again. This is the bold line right here, down to the stream, which is also a good thing to mark anytime you hit a stream. And notice that these two right next to each other, this value here and this value, 180 and 180 are the same. Then you're going to take the whole strip once you've gone all the way over to A prime, and you're going to line it up at the bottom of your profile box. Okay? And then you're just going to come along and you're going to go to 160. You're going to find that point and you're going to go straight up to the 160 and put a dot. The 180, you're going to go straight up to 180 and put a dot. 200, straight up to 200 and put a dot. Then you hit 200 again, you put a dot. Dot. Notice here, this is a stream, and notice the stream makes a V shape. This is key, and you'll want to do this as well. Then it comes back out, it pops back up, and we go dot, dot. This is at 200 again, which is up here, okay, and all the way up to A prime. Then what you do is you draw a smooth curve through the whole thing, coming back down to the stream. Every time a stream is intersected, you make a V shape, and anytime you go over the top of a hill, you kind of round it out. All right, so that's the general gist of it, and I'll show you a more detailed example in the next slide. So here's the topographic map that we made earlier in this module. I've highlighted all the contour lines. I've just drawn them in for different colors. And I have a topographic profile box here down on the bottom of my screen and elevations in meters. I have a contour interval and north arrow. I didn't bother to put any kind of scale on the map, but typically there would be a scale. So I want to go from A to A prime. Here's a point of intersection. That's a data point. Another point we're interested in, another one, another one, another one. Notice we're going up and then back down the side of a hill, around a hill. Okay. Okay. So the first thing to do is to drop straight down. If your box is aligned with your A to A prime, so that means the base of your box where you have the distance values is parallel to A prime, then all you have to do is drop straight down with a ruler. So what I would do is line up a ruler right next to this yellow thing, this yellow dash line, and then right where that ruler intersects A to A prime line and my contour, I'd use that ruler to follow it down and come down as close as possible straight below that point and plot it. The value, the contour value there is going to be 60. And so I get my data point pretty close to, I drew it in PowerPoint, so it's not as accurate, but close to 60. Okay? So you're using a ruler to guide your position so that every time you come down, it's properly aligned. You would not want to do this data point over here, this data point over here. This is not correct. Okay? This is a big no-no. So don't do that. Use a ruler, come straight down. And this will work, I guarantee, for this particular lab. So my next data point's at 80. My next couple, I got 80, 100, 120, 120 again. I'm going over the hill. The next two or three I plot here, and I got down to 80, 100, 80, and 60. And then what do? Well, I draw a nice smooth line between all the data points ending the profile, right? And I've contoured all my lines. So here's an example we can do with vertical exaggeration. It's actually very similar to what I've just done. Okay? Every data point that intersects this line A to B, same thing, is a data point. We're going to use a ruler. I won't show you the ruler on the screen. I don't have a ruler on the screen, but I will just simply draw a few arrows, and you'll want to use a ruler. You'll also notice we have this kind of fractional scale here. So what we're going to do is we're going to plot the profile, and then we're going to do a little thing where we do a vertical exaggeration calculation, which is pretty straightforward. Okay? So point of interest, point of interest, point of interest. One of the first questions you might ask here is, what is the CI, or what is the contour interval? The CI here, then we can figure out by saying, well, all right, here's 500, here's 600. There's 1, 2, 3, 4, 5 steps. So 500 to 600 is 100 divided by 5. The CI is equal to 20, right? So every increment, I'm going to go ahead and erase some of these marks. Every increment, every contour line I move up or down is going to be a value of 20. Let's come down to the left-hand side, the bottom grid here. We'll see 500 and 550, 600. And so that means that every 2 boxes, right, is equal to 10. 10, 20, 30, 40, 50. So that's 500, 510, 520, 530, 40, and 50. So to move an increment of 20, I need to move 4 boxes. Got it? 4 boxes. So the first one is easy. Here, it's the first contour of interest here is 520, right? So 520, I'm going to make a mark and come straight down. 1, 2, 3, 4 is right about there. The next one, and we're going uphill, is going to be 540. 1, 2, 3, 4. I'm going to put a mark or a dot right there. The next one is going to be 60. So I need to go 4 boxes. I need to move over a little bit. And so now I'm at 1, 2, 3, 4. There's 560. Next one is going to be at 1, 2, 3, 4. It's going to be at 501, 2, 3, 4, 580. Now we're going back down again. And we're going to come back down to 60, to 40, to 20. And then right in here, we've got a stream right there. And then not too far over, we're going to go back up, back to 520. Oh, now look, we're going up again. So we're here at 520, 40, 60, 80, 600. So we're going to go to 20 to 40. To 60. To 80. And then to hit 600 right here, we got to go up above 600. So we're going to go 1, 2, 3, 4. There's one there, and 1, 2, 3, 4. There's one there. Go over the hill, back down here. Put a point here, a dot there. We're coming back down. Now it's from 600, and we're going to go down to 580. So you'll notice all these points are kind of lining up next to each other. 580, 560, 40, 20. We're going to hit a stream, which is right there. So we hit a stream. So we're going to come down, and we go back up to 20. 40, 60, and we got to come back down, 60, okay, down to 540, and there's a little change in slope, 540 again. Remember, we got to get up to here, 600. So we got to go to 540. So let's see, 20 to 40 to 60 to 80. Now we're up here at 600. And we're coming back down. It's real steep there, so we got to come 1, 2, 3, 4. Very steep. Very steep. Now it's widening out a little bit. A little bit more. Here's our stream. We're down just below 520. And then we go up 3 from 20. So there's 20. We go 1, 2, 3, 4. 40. So that's that one done. And then the last one, 1, 2, 3, 4. And that's 60. Yeah, 60, and that's the last one. So now we have our plots pointed. We know where our streams are. And I'm just going to draw a smooth curve between all the data points from the end. I'm coming up, connecting those points, coming over, coming back down. Now at the stream, the key is to make a V shape, so you go down, but you don't hit the next contour because you didn't get to it yet. See, there's the 500 right there, and that line doesn't cross it. Come back up, connect all the data points, 2 points together. You're going to loop back over. You can do a little bit better job than I can draw on the screen here, I'm sure. Loop back over, come back down, back up again, back over, back down, all the way down to the stream, and then up and off. And that's our topographic profile. Now the question is, is the scale the same? So what's the vertical exaggeration, or VE? Well, we know what the fractional scale is for the map. I already highlighted here at 1 to 24,000. So now we need to kind of figure out what the vertical scale is on our profile. So the vertical scale is not something you figure out on the map. You figure it out from the scale in this box below. So I'm just going to measure from 500 to 550 meters, and I'm going to use a ruler. So I place my ruler there, and I get it as 3 centimeters. Okay, so 500 to 550 is equal to 50 meters. I know that it's 3 centimeters per 50 meters. Okay, so I want to get these units into the same. So fractional scale, you always need to have the units the same so you can simplify the expression. So that's equal to 3 centimeters per, let's see, we've got to add 2 zeros to go from centimeters to meters, or I'm sorry, to go from meters to centimeters. So this becomes 5,000 centimeters. Okay, and if we simplify that, divide the numerator by 3 because we want that to be 1. Divide the denominator by 3. We've got to do the top and bottom in the same way. We end up with something that looks like this: 1, 2, 1, 6, 6, 6. 1 to 1,666. That's my vertical scale. Okay. Now, let's put these on top of each other to do vertical exaggeration. So for vertical exaggeration, it's going to be vertical scale over horizontal. So we're just going to put a fraction on top of a fraction. The vertical scale is always larger than the horizontal scale, so your value in this case should always be greater than 1. Okay? Rarely is the vertical scale smaller than the horizontal because we're ideally stretching things out. And so we want it to be large number on top of a small number. I'm sorry, yes, large number on top of a small number, so it's greater than 1. So it looks like this when you write it out: 1 over 1,666 divided by 1 over 24,000. Okay, so this simplifies into this relationship: 1 over 1,666 times 24,000, okay, over 1, which is equal to 24,000 divided by 1,666, which is equal to do the math, 14.4 times. So the vertical exaggeration, the VE, is 14.4, and all that means that we've done here is we've taken this scale and we've stretched it, so it's 14 times larger in scale than the actual map. All right, so that's how you calculate vertical exaggeration. There are a lot of steps involved. However, once you've kind of worked it out once, and you know like where the different parts are, there actually aren't that many parts. The hardest thing, I think, for many people might be starting out by getting this top right number, which is your vertical scale. Remember, that's got to come from your measurements, but it's really simple to do. Do make sure you have a calculator and a ruler. And so that's it for talking about topographic maps, in particular talking about creating topographic profiles and calculating vertical exaggeration.